The next steps in the expansion of human presence in the solar system will be taken on the Moon. To be sustainable space exploration missions must succeed at using locally available resources as far as possible. Additive manufacturing technologies will enable the production of the many objects, tools, and components required to support ongoing activities. The ESA-OSIP PAVER study investigates the potential of using a laser for the layer sintering of regolith into paving elements for use as roadways and launch pads, the first essential infrastructure before building habitats and larger structures.
So our plan is to consolidate the lunar regolith material, that's the dust, and we want to sinter to a dense structure, so really large areas. PAVER and TU Clausthal together, they have a unique know-how in that field. They use big lasers for other projects like crucibles or semiconductor, and we use that know-how to have a fast processing of the ground on the moon. So you need a unique equipment and you need a unique know-how to sinter the material with laser radiation. And so we have very powerful lasers here, up to 12 kilowatt. And we have a laser spot of about 100 millimeters diameter. And this promises to be fast.
Paving the road is about sintering of large areas of lunar regolith on the surface of the moon. And it is to allow a better trafficability of all kinds of vehicles, either human-operated or robotic vehicles, so that they don't stir up too much dust when traversing the surface. LIQUIFER has two roles. First one is to develop different geometries for these kind of paving elements, and the other one is creating a technology roadmap to show how this technology could develop into a real lunar mission and application.
We are mainly focusing on the simulant itself, also the parts that we generate using this technology, mechanical properties, morphology of the structure. We are aiming to analyze if the structure is mainly glass or is crystalline. So far, we found out that it is basically possible to melt a thick layer, 15 millimeters up to 20 millimeters.
The PAVER study results provide a first step toward the establishment of a lunar base. They will lead to the construction of equipment capable of paving areas for road infrastructure, providing dust mitigation. In the long term, the project envisions manufacturing three-dimensional protective structures such as habitats, storage units, and hangars, providing shelter from micrometeorites and harmful radiation. The PAVER project will help establish a lunar surface exploration capability that supports lunar science and prepares mission operations required for the expanded exploration of the Moon and eventually the exploration of Mars.